looking at requirements modeling, and the goal is for us to understand how we model requirements. In the last couple of classes, we've talked a lot about specifying requirements with the use of a use case specification and also user stories, right? And in the last class, most especially, we looked at requirement documentation formats. The different formats with which we document requirements. We have the product requirement document, which product managers use in documenting requirements. We have the business requirement document and the functional requirement document, which business analysts use in documenting requirements. So we looked at all of these requirement documentation formats along with a sample of each and every one of them in the last class. So today we're going to look at how do we model, right, requirements. Just as we've done specification, specification is all about writing statements about the requirements. Modeling itself is about representing the requirements with a diagram, right? Let me, sorry, someone's mic is on. If you can help out, mute your mic, that would be helpful. Yeah, so let me give a bit of more information. If, just as Faith, you're in Calgary, Zophar is in Ontario, assuming both of you want to go to Manitoba for maybe ladies hangouts, right? And you ask me, Genesis, I need direction to a particular hotel or to a particular resort or to a particular place in Manitoba for both of you to attend or go for your hangout or for your vacation. And then I write it out for you guys that when you get to Manitoba, you look for this particular days, you take this bus going to this place. I write out the direction for you as a statement, as a text, right? On paragraphs. You agree with me that particular direction I wrote out for you on paragraphs or text is going to be helpful to you. But it would be much more helpful to you if I actually gave you a map that will show you the road, the paths, where the exact location of that particular place that you want to go in Manitoba, since you've not been to Manitoba for the very first time. Excuse me. So that is the beauty, or that is the importance of requirements modeling. No matter how well you think you write your user stories, you write your use case specifications, most times, if you don't spend time to, draw your requirements, present your requirements in diagrams, you might not properly communicate that requirement to your technical stakeholders in most cases. And this is where requirement modeling comes in. And the different requirement modeling tools, or should I say techniques we have the use case model, which is also popularly called UML use case. Under UML, let me not say use case model. We have UML diagrams or UML models. Under UML models, we have the use case diagram, and then we have the sequence diagram. These are the two popular modeling types under UML, right? Then we have process model. Under process model, we have flowcharts. We have cross-functional flowcharts. We have business process modeling and notation, BPMN. We have SIPOC. We have IPO. We have value stream mapping. These are the 6 types of process models that we have. Then we have the class diagram. An example of the class diagram is entity relationship diagram, ERD, or what people call database schema structure, right? How primary key, how databases interact with each other, right? So these are examples of requirement models that we have. There are so many of them. We have class diagrams. We have data flow diagrams. Under data flow diagrams, we have context diagram. We have DFD1, DFD2, and DFD3. DFD stands for data flow diagram. So these are different ways we actually model requirements. Back in the days, as at 15 years ago, 20 years ago, the business analyst was the one responsible for drawing all of the models. You see a functional requirement document, and you see almost 5 different types of models. You will see data flow diagrams there. You see UML diagrams there. You see process diagrams there. You also see class diagram, and then you will see what do you call it now? State diagram. But because of the democratization of BA, most of the modeling job, right? Most of the modeling work most of the technical models are now handed over to the likes of people we call solution architects, right? So it's the solution architects that are now responsible in drawing most of the technical models, like the sequence diagrams, like the class diagrams, the data flow diagrams, and the rest. But the BA or the product manager is still required to draw the flow. That is a minimum requirement that every BA or product manager needs to understand how to represent a process flow or a user flow in a diagram. So we are going to learn how to draw a use case diagram, and we're going to learn how to draw a process diagram. And the process diagram we'll be learning is one of the most popular and widely used process diagram, which is cross-functional flowchart. So if time permits us, we should be able to cover these 2 topics today. Starting with use case diagram. If you can flash your mind back when we talked about use case specifications, right? How we represent a use case, and a use case representing a function or functionality of a particular system or a particular solution. Now, a use case diagram is basically a requirements model that shows the relationship between an actor and a system. If you remember, when we were writing use case specification, there's a section that we call actor and interfaces, right? And there's a section that we call use case title. What a use case diagram does is to show us that relationship between that actor and the functionality and the system, right? Use case diagram has 4 key components. Whenever you see a use case diagram, if one out of these 4 components are missing, then the use case diagram is incorrect, it's invalid, it is wrong. So a use case diagram must have at least 4 key components. And these components are: 1, the actor. The actor is the person that is performing the action or making use of the functionality. So we have the actor. 2 is the use case. The use case represents the action or function that is being performed by the actor. 3 are the relationships. Relationships are what we use to communicate the nature of interaction between the actor and the use case. And number 4 component is the system boundary. The system boundary represents the perimeter, right? Let me use that word. The perimeter of all functionalities and features that the system would have. And we're going to take these components one after the other and then try to understand them better. Starting with, okay, first of all, let's look at this, a typical structure of a use case. We have the actor. We have the relationship, which is this line or arrow. We have the use case, which is this oval looking shape. And then we have the system boundary, which is this rectangle, this big rectangle. That is your system boundary. Now let's take a look at each and every one of these components one after the other. Starting with the actor. An actor can represent a person, it can represent an organization, or it can represent an external interface, that is an external system that wants to play a role in one or more interaction with our system. A case in point is this. An example is WhatsApp, right? Or, yeah, an example is WhatsApp. If you want to draw the use case diagram of WhatsApp, WhatsApp will be the system. So we'll draw a system boundary called WhatsApp. An example of an actor for WhatsApp could be a user like you and I. An example of WhatsApp, example of actor for WhatsApp could also be a business. People that use WhatsApp business, right? An example of an actor again for WhatsApp could be your phone camera or your phone microphone or your phone book, your contacts. That's because there's an external system that you need to allow permission for proper integration or interaction with your WhatsApp so that I can easily sync your contacts for you to chat with on WhatsApp. So an actor could be a person. You could represent an organization, a business. You could also represent an external interface or an external system that has an interaction with the system in question. The second component, let's talk about the rules, right? When you want to draw an actor. When you want to draw an actor, you must ensure that your actors are drawn outside of your system boundary. So this is your system boundary, like I explained. This big rectangular box is your system boundary. You do not draw your actor inside your system boundary. That is wrong. Your actor must be outside of your system boundary. It shouldn't be inside. It's the only component that must be outside of your system boundary, right? You need to make sure you adhere to that particular rule. Another rule is that when you are giving your actor's name, ensure you use a singular name that is relevant to the business. A case in point, if the name of the system or solution we are building is a medical solution, you will not be calling your actor customer. Neither will you be calling your actor candidates. Rather, a typical name for such business domain, solutions in that business domain will be things like patients, nurse, doctor, right? Pharmacist. These are typical example of names that you're going to give to your actors in that particular solution for that business domain. The same thing applies to if you are building a solution for a financial institution. You won't be naming your actors names such as patient or doctor or nurse. Rather, you can give them names such as customer, such as merchant, and the rest. Same thing with an e-learning solution. You have names like student, you have names like candidates. So when you want to name your actors, don't use a plural. It has to be a singular business relevant noun that you have to use in naming your actors. And then number 3, you must ensure that when you draw your actors in your use case diagram, each actor must have a relationship with one or more use cases. You can't have an actor that does not have a relationship with a use case. That is very wrong of you when you are drawing a use case diagram. So each actor must have a relationship with one or more use cases in your diagram. And the last one is that you need to have it in mind that actors represent a role and not position. What do I mean? Assuming, in workplace, we have different positions. When I say this is the role of a professor, let me use, this is the role of a professor. Let me use academic scenario, for instance. I say this is the role of this is a professor, and this is what a professor should do. And we have different level of professor. We have junior professor, we have senior professor. When we are drawing a use case and we want to represent professor, even though we have junior, senior, mid-level, executive professor, we only have one actor that is called a professor. We won't have junior professor as an actor, senior professor as an actor, executive professor as an actor. No. We're going to have just one actor, and we represent that actor as a name called professor. So your actors should not represent positions, first position, second position, first level, second level. No. it should represent that role that is being played in this solution. The next component is use case. A use case represents a function or an action that an actor would perform on the system. So any action or any function that your actor, who you have been able to identify, would perform on your system, that is what we call a use case. Things like create accounts, things like login. These are actions that will be performed by an actor on a system. So we represent these actions or these functionalities as a use case, this oval shape, egg-looking shape, right? Now, what are some of the rules we need to put in mind when we actually drawing use cases? Number one is that your use cases must begin. It's a thing of must. It must begin with a strong verb. And that is to show an action that is to be performed. So things like create accounts, register course, transfer fund. You see the strong verb, create, register, transfer, right? You won't title your use case as account creation. No, you're basically starting with a noun, and you don't start naming your use cases with a noun. A use case has a noun, but you must make sure that the very first word in your use case is a verb, right? Another rule is that your use cases should represent domain-specific terminologies. Just as when you are naming your actors should represent type of actors in that domain. Same thing with your use case. The actions and functions that need to be performed must relate to that particular business domain. For instance, if it's a financial solution, we will have use case names such as open accounts, deposit fund, withdraw fund, close accounts, delete accounts. Do you understand? So we have use case names like that. And that is because accounts, fund, withdrawal, fund as well, or deposits are financial terminologies. If we are building an educational solution, right? Instead of open accounts, we'll call it register. Instead of deposit fund, we'll call it select a course, right? Instead of withdraw fund, you can call it take a class. So with the word register, class, course, anyone can easily relate to the fact that this is an educational solution. And the same applies to every other industry or domain that your solution is operating under. Okay. Now, another rule for use case is that most times there's what we call primary use case. The primary use case is more or less like the very first use case that needs to be performed, right? And it is best practice. This is not a mandatory rule, but it is best practice for you to place it at the top of every other use case. So your primary use case, let it be at the very top of every other use case in your diagram. The next component we are going to look at as well is relationship. Relationship. You know, relationship is a word that is very common to everyone, right? In life, we thrive on relationship with people. If you are married to somebody, right, the relationship you have with the person is either husband or wife. If you are born from the same parents with somebody, the relationship you can have with that person is either brother or sister, right? If you work in the same place with somebody, the relationship you can have with the person is what? Colleague, right? If you attend the same school and course with somebody, the relationship you can have with that person is what? Course-mates. So in life, we thrive or we live with relationships, right? And we share different relationships with different people. Same thing in use case diagram. There are different types of relationship for specific cases. So when you're drawing your use case diagram and you identify a certain type of relationship, you need to make sure you use the appropriate diagram to represent that relationship. So there are 4 different types of relationships we have in use case diagrams. Number 1 is association. Number 2 is generalization. Number 3 is extend. And number 4 is include. I'll take it again. Number 1 is association relationship. Number 2 is generalization relationship. Number 3 is extend relationship. And number 4 is include relationship. Okay? Now, let's take these relationships one after the other to understand what they mean and when we can actually use them, right? Just like someone tell you, if someone say these relationships, colleague, husband, classmates, patient, and they say these are 4 different relationships. In the following use cases, what kind of relationship applies to this use case? They say man and woman married to each other. A man married to a woman, what kind of relationship applies? 2 students taking the same course, what kind of relationship applies? So, with our human knowledge and advancement and common sense, we can know that when we say 2 students that take the same course, the kind of relationship that applies to them is what? Classmates. Same thing applies in use cases. Once you understand the dynamics between 2 use cases or between an actor and a use case or between an actor and an actor, you will know the appropriate relationship to use in representing them. Let's start with association. An association is used to represent a direct relationship between an actor and a use case. That is what we use association relationships to represent. A direct relationship between an actor and a use case. We do not use association relationship to represent actor to actor. Neither do we use it to represent use case to use case. Association relationship is solely used for actor to use case relationship. Okay? And one way to identify or distinguish an association relationship is that an association relationship is just a line. It doesn't have an arrowhead. It's basically a line, this particular line. Some diagramming tool or modeling tools called association relationship communication paths. They are the same thing. For instance, Microsoft Visio, which is more or less like the legacy modeling tool, call it association. Diagrams.net or draw.io call it communication paths. So different tools might call it a unique or specific name, but it's the same use that it's the same function that is actually what performs. What are some of the rules that we need to, put in mind when drawing association relationships? Number 1 is that your association relationship must only be drawn between actor and use case. It shows the relationship between an actor and a use case. Remember, I've explained what an actor is. I've also explained what a use case is. When you are trying to show the relationship between an actor and a use case, just like when you're trying to show the relationship between 2 students that are taking the same course, we say the relationship is what? Classmates. So when you're trying to show the relationship between an actor and a use case, the relationship that you use is what? Association. Number 2 is that your relationships do not have what? Sorry, your association relationships do not have arrowheads. Okay? The second type of relationship we have in use case diagram is generalization. Generalization relationship is a thick arrow with an arrowhead. It has an arrowhead. and it is used to represent the relationship between a parent and a child, or as we call it in the technical word term, a parent and an inheritor. For instance, a parent actor and a child actor, or an inheriting actor. An inheriting actor is someone that inherits properties, functionalities from another actor, but have their own unique functionalities they also do, but they inherit certain properties or functionalities from another actor. Okay. Now, some of the rules is that your generalization relationships must have arrowheads, and the arrowheads must be drawn towards the parents. That means the arrowhead should be pointing to the parents, while the tail of the arrow is on the inheritor or on the child. I'll show you guys an example when I draw one. Okay. Generalization relationship are used for actor to actor relationship. Remember, association is what? Actor to use case relationship. Generalization is what? Actor to actor relationship. That is what we use generalization relationship for. Okay. And then another type of relationship is the extend relationship. The extend relationship. This particular relationship, when it is not mandatory for an actor to perform an inheriting use case after completing a parent use case. Let me give an instance. You know, they do say that let me give you an example. When have you noticed that sometimes when you make a call on WhatsApp, right? So let me know if you've identified this thing. When you make a call on WhatsApp, whether video or voice call, after making that call, WhatsApp will ask you to rate your call experience. Have you identified or noticed that before? When you just completed a call on WhatsApp, maybe video or voice? Anyone?
Yes.
Okay. Now, if you don't respond by rating your call experience, would WhatsApp say, oh, come on, because you did not respond to our request, we won't allow you to make call again? Is that possible?
No, it's not.
Or would WhatsApp say, because you failed to respond to this, we won't allow you to use our services, you can't chat anymore? Is it
No,
possible?
no,
So
it's
you
not.
can actually skip, you can skip it, right? You can close and skip, isn't it?
Yes,
But
yes, it is.
but that particular functionality of rating call experience only comes up when you make a call, right? If you are chatting with somebody, you're just chatting with me or you're chatting with anybody, would they tell you to rate your call experience?
No, they don't.
So that rating of call experience only comes up when you perform the functionality or the action, when you perform the function or action of what? Making a call, whether voice or video call, right? Now, when you are trying to represent such actions, these are two different actions: make a call, rate call experience. These are two different actions. These two different actors have a relation. Sorry, these are two different actions. These two actions have a relationship, and the relationship they have is what we call an extend relationship. It is an extend relationship because it is not mandatory for you to perform the inheriting. The inheriting use case here is, or the inheriting action is the rate call experience, while the parent action or the parent use case is make voice call or make video call, right? It is not mandatory for you to perform the inheriting action of rating call experience after you have completed the parents. So in a situation whereby we identify two functionalities that occur consecutively, but it is not mandatory for you to perform the inheriting one or the second one, then we use what we call an extend relationship. An extend relationship is typically something like this. It has an arrowhead, it has dotted break lines, and it has the title extend on it. there are some rules we need to put in place or put in mind when drawing an extend relationship. Number one is that your extend relationship, your arrowhead needs to point to the parent. So the arrowhead of an extend relationship points towards the parent. It doesn't point towards the inheritor. It must point towards the parent. The extend relationship is used for a use case to use case relationship only. You don't use it for actor to use case. Neither do you use it for actor to actor. You strictly use it for a use case to a use case relationship. Another rule is that your extend relationship, the inheriting use case, which we popularly call the extend use case, must be drawn below the parent use case. So the inheriting use case is drawn below the parent use case. That is it for extend relationship. Another relationship, which is the last relationship, is what we call include relationship. Include relationship is the opposite of extend. In short, when you see the way the arrowheads are, you see that for extend, it is pointing backwards, but for include, it is pointing forward. It's because these two relationships are what? Opposites of each other. Opposites of each other. It's just like when you say, when you say, what kind of relationship exists between two individuals that are happy together, that play along and do things together? A typical example is what? Friendship relationship, right? But if you now say, what kind of relationship exists between two individuals that are opposed to each other, antagonized to each other, and wanting to destroy each other, you see, it's an enemy relationship. So enemy and friendship are opposites of each other. The same way extend and include are opposites of each other. An example is, let me give a relatable example for you before I go ahead to explain what I have on my slide. When you try to create an account online, you enter your email address and you enter your password, you enter all that information, you click on create account. There's something that I normally tell you to do before your account creation will be completed. Does one have an idea? They'll tell you that we've done this thing. Make sure you do this before you can complete your account creation. Does someone have an idea when you're trying to create accounts online? Anyone?
Is it confirming the email?
Yes. They'll tell you that we've sent a verification link to your email. Confirm your email, right?
Yes.
If you don't confirm that email, they will tell you that your registration or account creation is not complete, right?
Yeah, most times you even have to proceed from there.
Yes, you can't even proceed from there, right?
Yeah.
So that shows you that these are two different actions that are being performed, and it is mandatory for you to perform the other one after you have completed one. So after you have finished inputting your information and clicking on creating your account, you are mandated to what? Verify your email. And you agree with me that if you already have an account with them, they won't ask you to be verifying your email, because verifying email only comes up when you are trying to create an account, right? So is this an action or a function that occurs consecutively after you have created an account? So for such relationship whereby you are mandated to perform another use case upon completing a particular one, like you are mandated to do it immediately, they come, like the parent one results to the child. Because you've performed A, B would automatically come up for you to perform, and it's mandatory for you to perform B. In such relationship, we use an include relationship to represent it. Okay? We use an include relationship to represent such relationships. What are some of the rules we need to observe when we are trying to use? Sorry, give me a moment, please. So some of the rules we need to observe when we are trying to communicate or represent include relationship is: one, unlike extend, whereby you draw the arrowhead towards the parents, for include relationship, the arrowhead is drawn towards the inheriting use case, which is the include use case. Okay, so the arrowhead is pointing towards the child, but for extend, the arrowhead is pointing towards what? The parents. Another rule is that include use cases are used only for use case to use case relationship. Sorry, include relationships rather. It is for use case to use case. You don't use your include relationship for actor to actor, neither do you use it for actor to use case. It is exclusively use case to use case relationship. Another one is that you must ensure that you always draw your include use cases to the right of the parent. Remember, for extend, you draw it below the parents. But for include, you draw it what? To the right of the parent use case. And then the last component, yeah, Faith, go ahead.
Okay, so is this plenty use cases, is it that we're supposed to just have it printed somewhere to remember the rules and what to do? Because I don't know if I remember. Is it when maybe you're doing it continuously, it's you get used to it?
Yes.
Okay.
Just like, for instance, now, let me give you an example. If someone shows you how to play a video game, right? You've not played a video game before. Let me use soccer, football, right? And they give you the pad of how to play a video game. And I tell you, X is to pass. You are seeing those buttons there. X is to pass. Triangle is to pass. O is to tackle. Box is to score, right? You see those buttons on the pad, on the joystick, right? When I start telling you, you say yes, okay, I remember, I know. By the time I give you the pad to play the game, upon playing, you realize that you'll be asking questions, which one is to pass, which one is to this? Right? It's because it's the first time you're actually doing it. But by the time you keep on playing that game, you play it that day, you play it tomorrow, you play it next tomorrow, it begins to become part and parcel of you. You no longer ask which one is to pass. Same thing with driving. The very first time you try to drive, right, you'll be tempted to look down so you know which particular stuff you're going to be pressing with your foot. You ask which one is for brake, which one is for throttle, which one is to accelerate, which one is this? Right? Which one is gear one? Which one is, which one is for trafficator? Which one is for, flashlight? Which one is for wiper? Right? And all of that. It becomes, and there are several rules. They'll tell you, if you are going left, don't go and trafficate right. You say, how will I understand all of these rules? But it only gets better when you continually practice driving, and it becomes part and part. It becomes like second nature to you. For me, this is a second nature to me because I have done them multiple hundreds and thousands of times. And it was also strange to me like this, right? When I started my journey, just as you guys are starting your journey. But with consistent, constant practice, it becomes second nature to you. Okay? So the last component is what we call the system boundary. The system boundary basically represents the system you're talking about. We have a component that represents the actor. We have one that represents the functionalities. We have one that represents the relationship. What we now use to represent the system is the system boundary. Any use case or any use case that is drawn outside of the system boundary is not considered a functionality of that system. We don't consider it to be a function or an action to be performed on that system. Put that at the back of your mind always. Any use case that you draw outside of your use system boundary is considered the functionality or action of another system. Okay? So that is one of the main rules we need to observe with respect to system boundaries. Now, how do we draw a use case diagram? Right? I put up these steps to help you as you're starting to learn to be able to, draw a system boundary. Number one is for you to list out all the functions and actions on the system. So when you are given a requirement, you should be able to identify what are the different actions or functions that will be performed on this system. You list everything out. The next one is now for you to draw the system boundary. That big rectangle, you draw it. After drawing that big rectangle, the next thing I want you to do is to now draw your actors. So you identify your actors. How many actors do I have? You identify them and you draw them outside of the system boundary, not inside the system boundary. You draw them outside of your system boundary. Once you are done with that, the next thing is for you to now draw the use cases, that is the actions and functions, draw them inside the system boundary. And once you are done with that, the last one will be for you now to link each of the actors or use case to use case, link them with what? Your relationships. So you link whether actor to actor, actor to use case, or use case to use case. You link them with your relationship. And if you follow these 5 easy, straightforward steps, you realize that you have been able to, you can draw any use case. You can draw use case diagram for any system in the world, in the face of the world. Just these 5 steps, just apply them one after the other. Once you apply these steps, I bet you, I can bank on you, any system in the world, you can draw the use case diagram. Okay. I don't know if there's any question before we get our hands dirty with a bit of drawing. Any question before we go to the mod? Zolfa, Faith, do we have any question? Please feel free to ask before we get our hands dirty in the mod. Sorry, I'm not getting.
Just as you said.
Okay. So for you to be able to, like as I mentioned, there are different tools that we use in drawing use cases. Different tools that we use in modeling. We have Microsoft Visio, which is the legacy conventional one from Microsoft, right? It's like they call it Baba for the Baba, right? Microsoft Visio. We have diagrams.net. Diagrams.net is a web modeling tool. It's available over the web. You can also download it and install it on your device. For instance, I have it on my device here. I could have chosen to open it on my device. So this is draw.io or diagrams.net. If I open it, you see some of the models that I've drawn in the past. We have diagrams.net. We have Lucid Charts. We have Miro, M-I-R-O. So if I come here and I say lists of modeling tools. So let me put requirement before they go and give me fashion modeling. Right. So you're going to, Jira is not a modeling tool. Who is giving this kind of stuff? Jira is not a modeling tool. Let's go to Wikipedia. So there are several lists. Let me make it more specific, basically. So Lucid Charts and other requirements modeling tools. Oh, 90% models for no. It's only giving me Lucid Charts. So yeah, this is better. So this gives so you see requirement only tools for BAs. Yeah. Where is this now? I just saw the list somewhere. This is what we call mind map. This diagram is called a mind map. It's a type of modeling that we use for, most importantly, brainstorming, mind mapping. That's what we use this tool. This is what we call entity relationship diagram, ERD. It's an example of a class diagram. So you see it here, ERD, entity relationship diagram, is a type of a class diagram, right? This is what we call this is a cross-functional flow chart. Something like this. These are just different modeling. This is looking more like a use case, a UML, but did not draw it well. This is a UML use case, but did not draw it well. Basically, it is poorly drawn, very, very poorly drawn. And that is why when you look at content online, you just have to be very careful so that you will not be misled, because this is a very poorly drawn use case diagram. There is no, you only have the use cases, you have the actors, you have relationship, but there is no system boundary. So it is very poorly drawn. So here they listed out the names of these tools. Look at the business analysis tools. We have Lucidchart, Glyphy, MS Visio, and more. So there are so many. I don't know why they don't have it in their stuff. So you can access Lucidchart online. Lucidchart is online as well. You can go to Lucidchart. You see Lucidchart, and you can start using it to draw. Right? It's a web application that you can just start using to draw your models. You can start using it to draw your models. You also have diagrams.net, which you can start using to draw your models. These diagrams.net, you can use it straight up to start drawing your models. We also have Glyphy. We have Glyphy, which you can start using. When I actually started learning business analysis, Glyphy was the first tool I used to draw my very first use case and process model in my career as a BA. It was the very first tool I used. That was because then there was nothing like Lucidchart or diagrams.net. It was either Glyphy or Visio. And then Visio comes with a paid Microsoft plan. So I don't have Visio on my laptop then. I was using Glyphy off the web. So Glyphy, you can use Glyphy, and then the parent of them all, which is MS Visio. So you need to download it. It's not available off the web to draw. That's why I say download Microsoft Visio. With this, you can download it for free. If you use this link, you can download it for free from SoftSonic. So that is basically the major tools. So this is Microsoft Visio, how it looks like, the interface. These are the major tools that we have for modeling requirements, basically. But for the purpose of today's class, we are going to be using diagrams.net. You can use any of them, any of these tools to draw, but let's use diagrams.net. That's because to start with diagrams.net is very easy, right? You can go to your browser and type drawio.com or diagrams.net or draw.io. Once you go there, you click on Start Now. It opens the tab for you to start your drawing, but to tell you to provide certain information. Remember, we talked about categories of functional requirements. I will mention things like authorization, authentication. You see a typical example playing out here. Let this load. I don't know why it's taking time to load. Why are you taking time to load? If it's taking time to load, I'll use the one I have in my system. Okay, that's load. So now it's saying save your diagrams to where? Is it Google Drive, OneDrive, your device, Dropbox, GitHub, or GitLab? Now, if I should say I want to save this to my drive, my Google Drive, for instance, it will ask me to, it will perform what we call external interface communication. It will want to communicate to my Google Drive and ask me to authorize. Google Drive will ask me to authorize. So watch here. Have you seen it? Authorize, which is a category of functional requirement that we call authorization. So authorization required. Authorize this app in Google Drive. I'll click authorize. Then to open a dialog. So what has just happened here is what we call communication of external interfaces with the use of what we call API. So Draw.io have integrated to Google's Auth0, right? Or this is pretty technical, basically. It's to Google's Auth0. The moment I clicked on that authorize, there is a trigger for the API. There's a trigger for the API to be initiated. and the communication between Draw.io and Google will be established. And it will pull up for me to select which of my Google accounts do I want to use. I'll select this one, and then it will ask me, do you want to continue? I'll say yes. Then it will allow, which is also continue. So once I do this now, what basically is happening on the back end now is that Draw.io have told Google, okay, I did not select something, sorry. Coming. I need to tick something. I need to tick. So connect yourself to Google Drive, save, edit, and whatever, right? Now, when I click this continue, what will basically happen on the back end is that the Draw.io have sent a request to Google via the API saying, give me these things. One, give me the details of this, the credentials of this person. That is the name, email, and password. I mean, the name and email, and give me access to this, to a location in your database for me to store information and get that information whenever I want, like to see it, to edit it, and to create and delete it whenever I want. Once I click on continue, I'm basically authorizing my Google Drive to what? Send the response of, they call it 200 or 201, which is successful response, to say, okay, the owner said you can take them, carry it and go. Do you understand? Just like when you go to buy something and then you say, please, can you give me a packet of sugar, right? And the person say, oh, for you to get a packet of sugar, it is $1, right? Okay, you say, okay, here is my $1. But okay, the packet of sugar is all yours. You can take it. This is what's basically happening from a technological standpoint. So once I click on continue, that access will be granted, and then you see that Google Drive now is now the location that I'll store my work. That is how IT works, right? We've just experienced functional requirements. So I'll go to create new diagram. I mostly love to select blank, and I go to create. Title, I can say training. And then I save. Once I save, it will open the interface for me to draw my diagram. Okay? Yeah. So this is how the diagrams.net interface looks like. When you open yours might look white. Mine is looking dark because my Chrome browser theme is dark, right? I love that screen a lot. So that's why mine is looking dark. Yours could look white or gray, whichever one that you set for your browser. So to draw my UML use cases, I'll basically come here. I can come here and click on more shapes if I want more shapes, to select the actual shape for which I want to draw. Or to make life easy for myself, I'll just come here and type UML use case. Let me type use case. Yeah, so once I type it, it just gives me the search on those items. So this is my use case. This is my system boundary. You can click and they will appear, or you can drag and drop. So if I drag it, I can drag and drop, or I just click and it appears. This is my association, which I mentioned to you that some tools call it communication paths. Diagrams.net or Draw.io call it communication paths. This is it. It doesn't have an arrowhead. This is my generalization. You see it titled generalization. So let me zoom in a bit. See it titled generalization. And it has an arrowhead. This is my extend. So this is my extend. It's always face back. The arrowhead is facing back, and it should be titled extend. And then let me zoom in a bit more. Yeah, it's better like this for you now. This is my include. Then bring include lower. Or let me bring this one lower so that there'll be a clear comparison between include and extend. So this is my include relationship. So this is a typical example of all the, these are all the components that we have in a use. Oh, sorry, one more person is missing, the actor. And we have the actor, this handsome or beautiful looking lady. So these are your components, the 4 different components. 1, actor. 2, use case. 3, relationships. And 4, system boundary. These are the 4 components of a use case diagram. We are going to now draw our use case for the IBA e-voting solution. Let me see if I have that here. Yeah, so these are the requirements that we've been working with all along. So these are the requirements which we have written use case specification for in the past, right? So I think we shouldn't, no need for us to go through these requirements again, right? Ladies, do we need to go through them again, or should we just go ahead to draw? If you have it at the back of your mind. Can you hear me?
Can you hear me?
Yeah, I can hear you now.
Okay. Okay. Yes, it's okay. We already.
You know the requirements, right? How about you, Faith?
Yes.
Faith, how about you? Okay, so since you say you know the requirements, brilliant. Now you are going to do something for me to let me know if you actually know the requirements. I want you to list out all of the actions or functions of this particular requirements. So let's go one after the other. Number 1, people have to provide me with at least 10 functions or actions that are being performed on that requirement. So let's go one after the other. This person will say 1, the next person will say 2, the third person, the next person will say 3. You say 4, you say the 4th one and the rest. So let's go.
Yeah, I was out for like a few minutes, so I went to get something to eat. Sorry.
Okay.
I don't even know where to stop.
I'm saying that the requirement for that IIBA e-voting solution, you are very much in sync with it, right?
Yes.
No need for us to read it all through again.
No, not at all.
So I want both of you to provide me with the actions or functions on that e-voting solution as was given to us on that requirement, on this requirement here, this requirement document here. So
password reset.
Oh, someone is doing a Joro, looking through it again.
Where?
Yes.
Who is this?
Is it me?
This should be Zolfa.
No, I didn't see my password. I didn't see my screen.
No, so it's not saying. I think because we are there, so you know who is.
I'm not.
I know who. That's why it's online. I'm used to remote work, so I know who is using a document.
Okay, I'm not using it though. I'm not on it.
Okay, it's Faith.
I went to open it. Oh, now look at it.
Sharp lady, nice one. Go ahead.
I was supposed to look at it, Nabi.
So go ahead. Yeah. So if you mention.
I know reset password.
Okay. Faith mention after once you mention Zolfa, Faith to mention the next. People take it in alternating.
I know the first time login.
First time login.
And then they said there's also another one, log out.
No, you mentioned you allow the next person to talk. So alternatives.
Oh, okay, sorry.
Oh yeah, Zolfa. I need nothing less than 10 functionalities. Let's go.
Log out.
Really?
Okay.
Zolfa don't talk my own. No.
I go talk.
Oh yeah.
It's just.
Please say the next one.
active. I don't know, as an inactivity or something.
So that is not an action, or it's not a function. Yeah. So when you're drawing use case, you don't draw things like non-functional requirements. You're focused on the functionality of the system. So
how about viewing profile of all candidates?
Okay, view candidates. Zofa, you are next.
Voting.
This profile.
Cast vote. Cast vote.
You are learning.
Cast vote.
View candidate profile. Cast votes. Remember? So we call it cast vote. Oh yeah, Faith.
Submit votes. Submitting their vote. Submit vote.
You can put them in the same way to cast, and when you cast your vote, you submitted your vote, basically. So let's just group it in the same. Let's not, yeah. Maybe when we are writing the specification, we can now
open election.
Wait, let's Faith land.
I will now say your own now. You see, you don't cast yourself.
Oh yeah, talk.
Okay,
Faith.
so receive acknowledgements.
Email.
Acknowledgement mail.
Yeah.
Okay. Or maybe we can put it as receive acknowledgement mail. I'm not sure the best way to put that.
So go ahead. It's all for your time. You say open election, right?
Yeah, open election.
All right. Faith.
Rating their experience after voting.
Rates election experience, right?
Yeah.
Close election.
One. Close election. Faith.
Upload candidates info.
Awesome.
I don't know if that makes sense. Oh,
Yeah.
Okay.
Yeah. Okay, let's keep going. Let's get it coming.
Okay.
There are more.
There are lots, but let's just stop at 11.
Lots, actually.
One more. Let's
One
stop
more
at
for
11.
Zofa.
Yes, Zofa.
I can't remember.
Oh yeah, Faith, bail us
Help
out.
me.
So upload eligible voters data.
Countdown timer.
No, that is not a
not
functional
functional,
requirement.
Oh, that's
Yeah, it's just something that you see. It's a display, communication. Upload.
Wow, this functional.
Upload eligible.
I should not go back to watch the video again.
Voter data. Right?
Okay.
So, you know what you're basically doing? You're basically following these steps that I listed out here. I said first one is list out all the key functions and actions of the system. Right?
Yeah.
Okay.
That's what I'm following. I want to show you that it's actually easy to draw this. Just follow the step that I've listed out here. So we have listed out the key functions of the system. Next thing is now for us to do what? What is the next step?
Draw the system boundary. What does that mean?
So, you don't know what system boundary is? This is our system boundary.
All those things, like.
So these are our system boundary, this rectangle. So we'll draw it because we are looking at almost 11 to 10
because
functionalities.
Everything must be inside, right?
Not everything. All your use cases must be inside. So these key functions and actions that you've listed are your use cases.
Okay.
They'll be the title of each and every of your use case. Are you following me now?
Okay.
Yeah.
Yeah. So you have this, right? This is your system boundary. So you name your system boundary what? IIBA e-voting solution. You can see it's IIBA e-voting solution. So anybody that looks at it will know, this is a model for this particular solution. Now, what is the next process here? Sorry, please give me a moment, please. All right, so sorry about that. The next step is to draw your actors outside of your system boundary, right? How many actors they say we have? We have 3 actors.
Yes.
So there will be 3 types of users, that is actors on the system. Super admin, right? EMC,
EMC.
and what?
Eligible
Eligible voters.
voters.
So I'll pick up my actor shape. You see it's an actor. I'll pick this beautiful looking lady, bring her here. And then first one, super admin. I can go back and select, but let me just use a trick called to duplicate. Control D.
Okay.
I'll duplicate. Oh, sorry. Control D to duplicate. Then I drag this one here. I'll call this young man eligible voter. Let me bring him down. Then Control D again to duplicate. Bring this young one down here. I'll call him EMC. Let me bring this down more. I bet you will need the space. Okay. So we've done the first step. We've done the second step, right?
Yeah.
This is the third step that we just concluded. The next one is to do the fourth step. The fourth step says what? Draw use cases where?
Inside the system boundary.
To represent the functions, right?
The functions. Yeah.
So we'll take our use case, right? Take this first one. And there's a rule that I mentioned when we are drawing a use case. And that rule is this. Let me go to use cases. It says primary use case should be placed at the top of every other use case. What do people think, or what do people feel is the primary use case here? Would be the primary use case. There are actually 2 contenders. There are 2 contenders.
Is it the login?
Login is also a contender. Which other one is the second contender for primary use case that we can consider as primary use case?
Reset password.
No.
Cast vote.
No.
Faith, are you there?
So you can have things like so we are pretty much on the track. Login is like a primary, one of the primary things that can be done. Yeah, cast vote as well. It's one of the primary things that are being done on an e-voting solution to cast votes.
But casting votes, is that a primary thing? But that's not like the first thing, right?
It's
So
not the first one, but it's more or less
first
like the primary thing as well. So you can look at it as primary from, you can communicate your primary from the first thing to be done or the main function, the primary function of the solution.
Is it not being able to log in?
Yes. So you can look at it as from point of login or open election. But again, before you open election, you have to log into what? Open the election. So we go with what? Login first. So this is just it. The title is login. Put it at the top. So I'll do my Control D. Yeah, go ahead, Faith.
So I have used Lucidchat and Basmic or something. Is it Basmic?
Balsamic. Yeah.
So now there's this one. There are plenty of wow. Which one do you do companies? I know Visio is the one that most companies I see in the US, say, hey, you should have experience. But
I don't know why.
Do
you know why they say Visio?
Why?
That's because most companies use Microsoft's services, right? Visio is Microsoft. Just like you have Microsoft Word, Microsoft PowerPoint. Visio is Microsoft Visio. So it makes it easier for them. So they want to know if you use a tool that they use in their place of work. So Diagrams.net is open source. You can use it off the web. Lucidchart, so you can use it off the web. But what is most critical in all of this, and I keep telling my students, is if you don't know how to draw it, even though they give you paper, you won't be able to draw it. But if you know how to draw it, and you go to a company and it is Visio that they use there, you don't have any issue. The shapes or the components are the same. Whichever tool you are using is the same. Do you understand? Let me go to Lucidchart and you see, for instance, I don't want to go ahead and create an account on Lucidchart. That's just why I don't want to use Lucidchart. You see the way I did diagrams.net, I did not create an account, but you use Lucidchart now to start telling me to create an account if I don't want. Let me just go to Lucidchart just to show you. Right? It's the same. It's the same. So let me go try for free. Come on, people don't have continue with email. Show me Google. Show me continue with Google. Let me use Google to continue.
I think it's there. Continue because
yeah, it's going to it's there. It's loading basically. If you see here, it's
okay.
loading. It's loading. So use this. This is the same authorization that we did with draw.io. The same authorization, right? I put that into contact support. Okay, that is open. So this is the diagram I've drawn before with Lucidchart in the past. This one is BPMN. Oh, this is a BPMN that I drew in the past with Lucidchart.
Oh, so you already had an account, too?
Yeah, I have an account. So this is a BPMN. This is an example of a process model. I think I drew this way back in 2019 or 2020. Can't remember. So this is it, right? So let's say I want to draw a new diagram. Assuming I want to draw a new diagram, and I go to new. Trying to whiteboarding, please. The longer I use it,
you need not Lucid. I don't even know what the difference is.
I think, let me see which one they have. Let me open this blank. So if I want to draw a use case, right? This is for flowchart. If I want to draw flowcharts, shapes. Let me search for use case here. Use case. So you see that the shape here is still the same. Actor is an actor. This system boundary. Right? Oh, maybe later. Let me go to the relationships.
Oh, that's an actor.
Yeah, this is an actor. See it here, which is the same actor we have here.
Okay.
So what I'm basically trying to say is that they are all the same. All you need to know is the components and how to draw it. You don't have any issue. You understand?
Okay.
Yeah.
Okay. Thanks.
So if I say extend relationship. Oh, this chart is so complicated, unlike draw.io that is just very simple.
Okay.
But what I'm trying to explain to you is that irrespective of whatever, the way you draw this here is the way you draw it in Visio because the shapes are the same.
Okay. Across board. Okay.
Across board. So we have login. We have upload candidates. Data. Control D, that's what I'm doing to duplicate. Control D. We have upload eligible voter data. Next one is to The next one is to view candidates profile. Let me bring this down. Next one is to cast votes. I'm just doing. I'm starting my use case titling with name verb,
Okay.
not vote cast. Cast votes.
Okay.
Upload, not candidate data upload. Upload candidate data because it's an action that needs to be performed. Next one is rate voting experience. Next one is to receive acknowledgement mail. Next one is to log out. Next one is to open election. Next one is to close election. Let me drag. Next one is to, let me put one more that we publish election results. Okay. So we have all of our use cases stacked, right? Then the next criteria for us, is now then to link the actors and the use cases with the respective what? Relationships, right?
Yeah.
So we're taking this one after the other. Login. Eligible voter logs in, right? Super admin will also log in. Same thing with EMC will also log in. So we take our communication part. Remember, actor to use case relationship is what? Association. So we take our communication part, drag this here. Drag this here.
Why is the eligible voter outside? Okay, it's part of the rules, right?
Is an actor. Is an actor. Remember, actors are outside.
Okay.
I know you mentioned that you stepped out when I was teaching at some point.
Yeah.
Or if you look at the rules.
Those rules. They're just plenty to remember, no vex. I was there when you explained the rules, yeah.
So see the rules. Draw actors outside of the system boundary. Okay. They are not inside. Only the use cases are drawn inside.
So this space, this one that is this brackets where you have all, I thought this one's like login, this use, I thought they are called the system boundaries. So I was thinking when you said draw.
Yeah, this rectangle, this big rectangle here, this rectangle is what we call the system boundary. The perimeter of the system. Let me use mathematical terminology. The perimeter of the system boundary. Okay?
Yeah.
Yeah. So let me also do Control D to duplicate. Remember that actors only have an association relationship with use cases. Right?
Yeah.
I'll do this. For upload candidate data, which actor does that?
Eligible voter.
Oh, really?
No. EMC, right?
Ah, really?
Super admin.
That's the third option.
Super admin. So it's in the requirement. That's why I ask if people still remember the requirement. Look at it. The super admin will be in charge of what? Uploading the data of candidates. Uploading the data of eligible voters.
That's true.
So we are doing this thing as in line with the requirement that was given to us.
That's true.
Okay.
So I'll do
all our assignments. We didn't do anything with the super admin. That's true.
That's why I asked if people still remember the requirement or we should go over it again. So
no, I mean we'll be checking.
Yeah.
Who does eligible voter data upload?
I think that's what we just checked.
Yeah, who does it?
Super admin.
Super admin.
Mm.
Okay. So I think this. Who views candidate profile?
Views candidate profile. That should also be the super. Okay.
No, that is the eligible voter. You view the profile and view the positions where you want to cast your vote. Remember? So I'll show
Okay.
you. There's one other functionality that we did not put as well. You can, so if you see here, eligible voter should be able to what? View the various vacant position.
Yeah.
You should be able to view the profile and manifesto of all candidates.
Okay.
Okay.
So it's what was given to us. That is why the requirement is here as statements. But in your model, you use what? Diagrams to represent it, to communicate it. So I'll do Control D again. Who cast votes? Eligible voter, right?
Yes.
When they cast votes, they will need to automatically rate experience, isn't it? Because when they log in, they won't rate experience. Rating experience comes up when they cast votes, right?
Yes.
So that means rate experience don't have a direct relationship with an actor. Rather, it has a relationship with a what? Use case. So what kind of relationship will it have? Rate voting experience. Anyone?
Is it a direct relationship?
What kind of, there are two types of use case to use case relationship. There's extend and there's include. Which of them would this cast vote have with rate voting experience?
I don't know.
Okay, how about you, Sofa?
I'll say include.
Why?
Because you have to cast the votes before they can rate experience.
Okay, so let's look at the rule. I don't want to say the answer, but let's look at what the rule says. I know the answer, but let's look at the rule. So let's go back to relationships, right?
Okay.
And so what the rule under extend says, this relationship explains when it is not mandatory for an actor to perform another use case after completing the parents.
Okay, then is
the parent here is to cast vote, right?
Yes.
And it comes up immediately after casting vote. It's not is it mandatory to be performed? Yes or no?
It's just like the WhatsApp one you said.
Yeah, it's not mandatory, right?
Yes,
so we use
it's not
extend
mandatory.
use case. Extend relationship, and this is our extend. You basically bring it, and part of the rule says that what does the rule says? The arrowhead should be drawn towards the what? Parents, right?
Okay, below.
The arrowhead should be drawn towards the parents.
Okay.
The use case should be drawn below the parents. So this is the parents. This is the inheriting use case, which is the extend use case. The arrowhead will be towards what? The parents, right?
Okay.
So the arrowhead will come here, and this will come here. And the use case is below the parents. That is just it. It's not complex. It's not rocket science.
If you see this thing on a normal day, you think it doesn't have meaning.
Yeah. But a software, someone who is a very good software developer will take a look at this and understand it without you even explaining to them.
Exactly.
Do you understand? Once they see this, they understand it. Yeah.
But maybe because I'm not in dev, right? Because
You're not a dev person. That's why. Yeah.
Yeah.
You don't come and encounter with all this. Rather, it's the developers that will tell you what they want. Deploy this for me or whatever.
Right.
Yeah. So as I said, I don't know if it is this particular cohort or previous cohort that I mentioned that software developers are like soldier. Pardon me to use this analogy. When Fela sang a song, say, "Soldier go, soldier come," that soldiers are like zombie. It's what you tell them they're going to do. So it is your duty as a BA to tell them this is where this particular thing should be. And they'll just implement. Their job is very sweet and easy. They don't wrap their head thinking what should be implemented. They just go ahead and implement. Let me put this here. So it's you, the BA, that will spend your time racking your brain, trying to understand how to represent it. And then once you are done, you now give them, voila, they'll take it. So log out eligible voter. Once they are done casting their vote, they will need to log out. Here. Then who opens election, who closes election, and who publishes election results?
That's EMC.
EMC, right?
Yeah.
So I'll bring this EMC down here. I'll control D this association relationship, bring it down here. Drag it from here and bring it towards the EMC. Bring this. EMC does all of this. Control D again for the last guy here. Let me select making my work very neat. Yeah. But there's one more requirement. Now, this is basically the coming. Let me pull this wide. Or let me take this guy back a bit and reduce this. Yeah. So this, you can say our use case diagram is almost ready. Right? What is basically pointing is that when you see this, you know who performs what on this e-voting solution at a glance. So any place that this actor you're having a relationship with is basically what he or she will perform. This actor, anything is pointing to is what he or she will perform. Anything this person is pointing to is what he or she will perform. This will help your engineers to, at a glance, know what they will do. Rather than when if you give an engineering person this requirement, what will the eligible voters be doing now? They'll start reading line by line to identify what an eligible voter is going to be doing. But from this diagram, at a glance, you can say, oh, the eligible voter will do this 1, 2, 3, 4, 5, 6 things. Why EMC will do these particular things? The super admin will also perform these particular things. It is easy for you to communicate with your technical team, with your model. Now, there's another requirement I want us to also there's a requirement that says this. Someone should read that requirement 21. What does it say?
The EMC should be able to vote, and they can perform all activities that an eligible voter can perform.
That means there's a relationship between eligible voter and EMC. Right?
Yeah.
What kind of relationship would that be? Anyone? It's a very simple answer.
It's not association. You can check.
No, it's not.
The document.
So it will be a generalization relationship. That is the only type of relationship that exists between an actor and that exists between two or more actors. Generalization relationships have arrowhead. They are used to represent actor-to-actor relationship. Do you understand? So I'll pick up. So you see the name here, generalization. So I'll come here, pick it up. Now, and this is not just about knowing which relationship to use, it's to knowing how to represent it. Which one is the parent? Which one is the actor? Who is inheriting functionality from the other person? It says here in our requirement that the EMC should be able to vote. Hence, what this person can do, that means they're inheriting all of the functionality of an eligible voter. Do you follow? An EMC inherits all of the functionalities or actions of an eligible voter. That means the EMC is the inheritor, while the eligible voter is the parent. So I'll put this here and take this and put here. Because why I did this, oh, come on, make this straight. Why I did this is because the rule says that inheriting actors are placed below the parents, and the arrowheads are drawn towards the parent actor. This is the arrowhead. It should be drawn towards the parents. When a technical person sees this, you're basically telling them that these two people, they share relationships, and everything this guy can do, this person can do it. However, what this person here can do, this guy cannot do some of them.
Oh, okay.
So eligible voter cannot open election, right? Eligible voter cannot close election. Neither can eligible voter publish election results. It is the duties and responsibilities of the EMC to open, close, and publish election, right? But they also tell us that the EMC should be able to what? Has to vote, and they can do everything eligible voter can do. That means EMC can view candidates' profile, EMC can cast votes, they can receive this, they can log out, they can rate voting experience, and what have you.
I have a question. That means
Yes.
the EMC has more rights than the eligible voter.
Based on the requirements we are giving. Remember now, this requirement is from IIBA. It could be that maybe Chartered Institute of Accountants in their own requirement, they say, we don't want our EMC to participate in the election. Their responsibility should just be to only open and close election and then publish results. For that purpose, we will not, this regionalization relationship will be absent. Do you follow? So far?
Yeah, and just as Faith said, if I'm going to logically analyze it, can you hear me?
Yeah, I'm listening. Loud and clear.
If I'm going to analyze it logically, since EMC can perform more of the duties, I would think they are the parents.
Exactly. That was my question.
Exactly. I would think they are the parents.
So if it doesn't apply that way, an inheritor, right? When it comes to actor relationship, an inheritor is someone that can perform something unique and specific other than what the parents can perform. Now, if the EMC is here and the actor is the one down, you're basically saying that everything that EMC can do, the actor can do it. The eligible voter can do it. Do you get me now? So this guy is inheriting functionalities from this guy. When the EMC is logging in, the EMC is seen as an eligible voter. Are you following me now? When the EMC is logging in, let me give another example, right? Let me give another example, another relatable example for you guys, for you to know. Now, assuming we have an e-learning portal, right, where students can log in, take a class, right, select courses, right, submit assignments, participate in discussions in the course. Are you following me? And then we have, that is a student is a type of an actor. They can do all of these things. Then we have another type of actor called admin officer or registration officer. Do you understand? Registration officer's responsibility or actions are to, one, review student application, isn't it? Another thing that registration officer also does is to approve students' course application, right? Now, If that registration officer decides that I want to take a course in that school, maybe he's a registration officer in the arts faculty, but he wants to take maybe an MSc program in probably computer science. At the point of trying to registering for us, when that registration officer wants to register on the e-learning portal, that registration officer is registering as a what? Student. Is the person going to register as a registration officer?
No.
He's going to register as a what? Student. So the role that the registration officer will take when registering for a course will be what? Student role. But when they want to perform their own unique task of reviewing student application, they take the role of a what? Registration officer.
Okay. So in that case, he's an inheritor.
Yes, he's inheriting the role of a student whenever I want to register for a course.
Okay. Okay.
Are you following me now? Same thing with this EMC. The EMC's major responsibility is to what? Open election, close election, and publish election results, right? But they told us that the EMC should also be able to what? Vote. It means when the EMC wants to vote, we'll look at the EMC as an eligible voter because their votes will be counted along with the vote of other eligible voters, isn't it? We won't say, okay, this is the vote of EMC, this is the vote of eligible voters. No. The votes that will be counted or that will be considered valid are votes from eligible voters, right? So when the EMC wants to cast a vote, he will log in as an eligible voter. The system will recognize him or her as an eligible voter. So the EMC will basically inherit all of the functionalities of an eligible voter when they want to what? Vote. Is that clear enough?
Yes, it is.
How about you, Faith?
I hope Faith is there.
Yeah, I'm here.
Okay.
All right. So that basically is it.
And then I have one more question. This document now, is it different from when we'll be drawing? Because you remember the one you showed in Lucy Charts? That's the one I know. I've never seen this one where it looks this one looks like more simplified one, right? Like you're not putting all the connection, blah blah blah, like you're not putting the flow. So is that a different type of UML than this one?
No, that is a different type of diagram. Remember when we started, I said there are different type of requirements modeling techniques. We have UML. Under UML, we have use case model like we drew today. We have sequence model. And then we have process models.
That's the one I know.
Yes. Under process model, that's why you draw the step by step, right? You show the connectors, you show decision and the rest. That's process model. Then we have entity relationship diagram, which is an example of a class diagram where you show, I think there's a website that I opened and I showed you guys that, right? Let me go to my history. No, I'm not sure it is Lucid. No. It's not Lucid.
It was on one website like that.
Yeah, I searched with something. I said
diagrams,
requirements model, list of requirements
model.
Tools,
yeah.
Then it showed me something. I think I typed Lucy Chart and something. It showed me something. I can't really remember. I'll remember again.
No, is that list of this thing
requirements models, Abby?
Yes. So you scroll down. If I see it,
so this is an example. This is ERD class diagram.
Okay.
Do you understand? This is class diagram, entity relationship diagram. For database, these are different databases: supplier database, order database, order detail database, order delivery database, products database, headquarters. So this ERD shows the relationship between different database schemas. We have process diagram. You see process flow diagram written here. So this is an example of which is what we're going to learn on Wednesday, how to draw this. Are you following? So there are different diagrams, so many of them, different modeling. Let me just go list of requirements models, not tools now. List of requirements models. Let me see if this guy have the diagrams there. Oh, user story is not a requirements model. Why do people just, so we have flow diagram, which is process model, activity diagram, state diagram, sequence diagram. So many of them. When you go, you see different things on the online. You see those that to give you what you actually need, and those that to actually mislead you. Basically, that's why I want people to always make sure you dedicate time, check things online. If you have any questions, reach out to me. I'll guide you. Okay, I'll guide you guys to which is which. So,
I don't know why everything just kind of feels like a lot, because it feels like different people have the different way they do things, and you're not sure which company you'll be getting into and what they do, and if they use.
so
You know?
as I mentioned earlier, Faith, you don't need to feel
No,
overwhelmed, right? The simple truth is this: know what each of these components represents,
Okay.
and then how to draw it. If I use Lucy charts to draw this thing, it will look exactly like this. It's the same way it's going to look.
No, I wasn't even talking about the diagrams and stuff. I'm just saying.
Talking about the tools, right?
Yeah, everything.
Which is where YouTube comes in handy.
Right.
Which is where YouTube comes in handy. As long as you know how to use those tools, right?
Okay.
As long as you know how to use those tools. If it is Lucy Charts, just come and search Lucy Charts. You see it like a 10-15 minutes video that will teach you how to use these 7 minutes, how to use Lucy Charts. You see short videos on how to use Lucy Charts. All you need to know is just to know how to guide yourself and land in this particular space to start drawing. But these things are not difficult to do. Once you are tech savvy, you can go through them.
Okay.
Yeah. Where the main issue is knowing how to draw this. That's offer.
Okay. Although me, I've not really worked in this space, but I think what Faith is concerned about is as in different approach based on domain, I guess. But I think till you get to a particular domain that you find yourself, then you know what you are really looking for.
So
let me also basics. Okay. Yeah, sorry.
Yeah, let me also reiterate again. Whether it is in a medical domain or fintech, right? Or edutech or social tech or cryptocurrency, blockchain, whichever domain or whichever company, whether it is a Microsoft-driven organization or Google-driven organization or whatever, whichever company it is, the way you will draw it is the same. The only thing that might differ is the tool that they use in drawing it. Some might use Microsoft Visio in their place of work, which is part of the tool that they use in their place of work. Do you understand? Just like, for instance, when I was talking about user stories, some companies use Jira, some use Azure DevOps, some use Octane, some use Pivotal Tracker. But the way to write user story is the same all over the world.
Okay.
So irrespective of whichever tool, you can learn how to use a tool with a short 15-30 minutes video if it is new to you. But how to do that particular job, you know it is the same everywhere. How to draw use case in any company or in any industry is the same. UML use case diagram is the same. It's the tool that might differ, whether it is Visio or diagram draw.io or Lucidchart or Miro. Miro is another one that other companies are also adopting as fast as possible. Most companies are now adopting the use of Miro, right? You can also use Miro to draw anything, as well, both wireframing, mind map.
I used to think it was just for collaboration, as in before.
You can use it to draw anything.
Okay.
Do you understand?
Okay.
So there are so many tools. So don't go killing yourself about tools. Know how to draw it. If someone asks you, let's say in your CV, maybe let's say assuming, for instance, someone asks you that which modeling tools do you use or do you know? It's okay. I know how to use. I know I've used that draw.io. I've used Microsoft Visio. The person I say, well, in our place of work, we use Lucidchart. I say, oh, fine, that's brilliant. The principles of modeling is the same everywhere. I believe that once I pick up Lucidchart, I can play around it within 30 minutes and understand it. Shikina, you don't have any issue.
Okay.
You mustn't know how to draw with Lucidchart, Visio, all of them.
Okay.
You mustn't. What you need to know is the principles of drawing it. Then any tools. Do you understand? And
Right.
just for instance now, if you know the principles of thermodynamics, right? If you know the principles of thermodynamics, if you are answering an exam with a sheet of paper, you know how to explain it with that paper, isn't it? On that paper. If you are to answer your exam on a laptop, on a computer, you know how to explain it because you know the principles. But if you don't know the principles of that thermodynamics and they ask you a question on that, whether they give you an AI interface to use to answer your question, you won't be able to know what to do. Or they give you a piece of paper. So the tool might differ from companies, but the principles of doing that thing is the same. And you can learn the tool with just a quick video on YouTube. Or you can tell me and I'll teach you whichever tool it is. I've used most of those tools. Visio, Lucidchart, Glyphy, Draw.io, Miro, I've used all of them. And most of them is not because my place of work uses them. Sometimes I just want to learn a tool and I just go online and I just pick it up. When Miro came out, I picked it. I was the first person that used Miro in my place of work and I started inviting my colleagues. Do you understand?
Oh, okay.
So, yeah. All right. I think we are right o'clock or right on the dots of our time.
Okay.
Next class, we'll pick up process model. Okay, look at cross-functional flowcharts as well, how to draw it, and then